So, hi everyone, welcome back to my channel. In this series of straight lines today for coordinate geometry, today we have already learned that how we can represent a line which is parallel to x-axis and how to represent which is parallel to y-axis. But in this video, we are going to learn that how to represent a line which is inclined at some angle with the x-axis, right? So watch the video till the end to understand how to get the equation of a line like this. And if you like the video, please do subscribe. Okay, so let's start with the solution to it. So so what happens whenever, like in any situation, when you need to find the equation of a straight line, you should always keep two things in mind, that you need two information, right? With these two information, you can find out the equation of any line. So what are those required information, right? Required info. The required information for finding the equation of any straight line is that, one, you need to know the slope of that line, right? One is the slope of line, and second, any point through which the line passes. So if you have these two data, you can find out the equation of any line, right? So now let us understand first what is the slope of a line, right? So considering this line here that we have, right? It is L. So for this line L, what we can do is that uh, if let us assume it passes, and the second is any point through which the line passes, right? So let me assume it as a point known as x1 comma y1 through which it passes, and let me draw a line perpendicular to it passing through it, and let this point be named as A, this point be named as B, and where it is having the perpendicular as C, right? One second, I am drawing it again because I think uh, it's not good. It will create confusion. So here is the construction that I am doing. Right. This is the construction. This point is named as A. This point is could be named as B, and this point could be named as C. Now, what is the slope of a line, right? If you will ask me the slope of a line, it can be the slope of line L. So the slope of line L is equal to the tangent of this angle alpha, right? And we can write the same thing also as AB by BC. And sometimes this slope of line is also is denoted by the small letter m. So these are known as the slope of line. By slope of line, we can get an idea that how much a line is inclined to the x-axis and also with the y-axis, right? More the value of m, you can see, the more we increase the value of AB, the more it gets closer to the more it gets closer to vertical line, becoming a vertical line, and more we decrease the value of m, the more it comes nearer to a to x-axis. You can easily visualize that, right? Suppose I draw a sample line here. This one has some angle alpha 1, right? Let us assume it as having alpha 1. Now we can easily see that if I name this point as D. So what will happen, and if for this line L2 passing through the same point where on x-axis this line L passes. So slope of line L2 will be L2 is equal to tan of alpha 1. Now tan of alpha 1 can be said as, I named this point as B, right? So it can be named as BD by BC. We can see that BC, the base for both of them is same. But here, what happens, let us take it as M2. We can clearly observe from the figure, right, that AB is greater than BD, which means if we divide both the sides by with AB by BC and keep it as BD by BC, then what happens? The slope of AB by BC will be was B. This I kept it as M2. So we can see that slope of L is greater than L2, right? I'm writing it here. Slope of L is greater than slope of L2. So I think you have got like how we can judge line space, or based on the slope, how we can get a visualization of how much is the inclination of a straight line with respect to the x-axis and the y-axis, right? This L2 is more closer to, has less opening with respect to this x-axis. So the tangent of alpha 1 is same, and hence the slope of L2 is also lesser than the slope of L, correct? Now let us take any point x1, right? This. So what happens by definition when we represent a slope of the equation of such lines? It is defined as one second. No, sorry, like my pen is not working. Okay, it's working. So what happens? Like let us assume that we are considering that we have to find the equation of this line L, right? Equation of line L. Now we have taken a point here, x1, y1, through which L passes, right? This is our one information. Passes through x1, y1. And the second information is that it has slope of tan alpha, or we can also call it as M, right? So we have these two data. So equation of such line, so now what we will do is that we can take some random line here. I will take one random line point here. It is, let it be the xy, and let these xy be in such a way that these points satisfy all the points falling on line L, right? So now what I will do, I will do some construction again. Let me do it with a different color so that it is visible to you, right? I'm doing in green color. I can extend this, draw a line parallel passing through A, right? And then I can draw a line passing parallel to y-axis, which passes through, let this point be called K. And the point of intersection of these two perpendicular lines be M, right? Now we can see that CX is parallel to AM, and hence as angle ACB, right, angle ACB should be equal to angle KAM, because AM is parallel to CX, and we can consider this line L as transversal. So following the concept of this transversal line, right, we can simply say that it is also alpha. So now what we can represent the tan of this alpha here as something like tan of alpha can be here represented as, we know, okay, one more thing. Let me ask you the coordinate of x1 and y1. If you had watched the previous video, I would have told you that if a line is passing parallel through xy, right, and if a line is coming parallel through a and it is parallel to x axis, right? Then I think you should be able to predict the coordinate of this one, find out the coordinate of this point M. It will turn out to be x comma y1, right? X comma y1, not x1 comma y1. It's looking a bit bad. Let me write it again. It will look like, let me write it clearly here. So the what you have to do is that, okay, let me do one thing. Let me copy it, a section of this so that I can clearly show you. Let me copy this, right? So what happens here is that if I look into this in triangle AKM, right? We have tan alpha as Km upon Am. Now we can easily say that Km has some will be equal to these many units y minus y1, right? You can see here Km will be equal to y minus y1, and similarly here Am will be equal to x minus x1, right? So this is also known as the slope of this line, right? So if someone asks you what is the equation of a line which passes through x1 y1 and has slope m, right? Your answer should be y upon y1, y minus y1 upon x minus x1 is equal to m, which implies that y minus y1 is equal to m multiplied with x minus x1. So this is the equation of a straight line which passes through x1, x2, x1, y1 and has slope m, right? Basically, I have replaced this tangent with m because it's a usual convention that we have in a coordinate geometry. And so, okay, now let's go ahead with one example, right? So let's find out the equation of a line, right? It's I would request you guys to try first. Equation of line passing through let's take 3 comma 4 and having slope 2. Sounds good. Okay, so this is a question. You can pause the video for a while, you can try it yourself, and if you have tried it out, you can continue with me to check the answer, and if you are not able to come up with a solution, and so simply by substituting this, right, we can simply consider this as x1 comma y1, and we have the values, we will get the values as x1 is equal to 3 and y1 is equal to 4. So this turns out the equation by substituting this in the equation of line that the standard equation that we have here, we will get is as y minus 4 is equal to, here is the slope, right, which is equal to m. So y minus 4 is equal to 2 multiplied with x minus 3. And hence the equation turns out to be x minus 4 to x minus 6. And eventually, if you beautifully align it, this equation will turn out to be 2x minus y minus 2 is equal to 0. So this is your final answer for this question, right? And let's move to one more example, right? This time you had the value of slope. So this time this was one question. So let's move to the second question, right? This time I'm taking something like let it be in 0, 1 equation. You have to find out equation of a straight line aligned at 45 degrees, right? 45 degrees with x-axis and passes through let's say point 6 comma 5, right? So how to approach this question, right? I have already told you that the equation of a straight line is of the format this one, when we are aware of the slope and any one point through which it passes. So basically, this equation, I think you can see from here, although I have written it here again. So what will happen? The basic thing is that this m, right? M, I had already told you, is that m is the slope of a line. And you can see here clearly that alpha was the inclination with the x-axis, which was further taken as the and the tangent of this x was taken as the slope, right? So here we can easily say that alpha is equal to 45 degrees, right? And m is equal to tan alpha, which gives tan 45 degrees as 1. So substituting these values, we have here we have our x1, y1. Substituting these things, we get y minus 5 is equal to 1 multiplied with x minus 6. So it turns out to be y minus 5 is equal to x minus 6, which implies that x minus y minus 1 is equal to 0. So this is the final equation answer of this question. So okay, hope you guys enjoyed this video, and you like the concept and your fundamentals got cleared. And yeah, one more thing apart from all these is the regarding the concept of slopes. So let me erase for some yes, and then I can show you. So there are two special cases, right? You can note this down. Uh, Actually, there are some special cases in which you have to think about the slope, right? These are special cases. So whenever you get slope is equal to infinity or m is equal to 0, right? You have to take the inclination or angle alpha, inclination with x-axis as 90 degrees, because we all know that tan 90 is equal to infinity. And same for inclination with the x-axis will be 0 degrees, because we all know that tan 0 degree is equal to 0. So you have to keep this in mind, and if you have watched the previous video, you can easily see that if an that these are special cases of lines parallel to axis, right? You can check out the first video in the playlist and you can understand these topics. But the problem arises like how to approach a question when you get this, right? So let us assume that you have got a question. There is a line which passes through 3 comma 5 and it has slope equals to infinity, right? So when you're solving in reference to this equation, what you can do is that, sorry, let me erase it and write it. So what you have to do, you have to simply take x minus x1 by m, right? Take it as y is equal to, sorry, I am mistaken. X minus x1 turns out to be y minus y1 upon m, right? And since this m, it is going to infinity, you can simply go for writing x is equal to x1 as the straight line. This, I think you have understood the how this formula is related to the concepts which we learned in the first video. And similarly, if you get m is equal to 0, if you apply this formula, you simply get as m is equal to 0 multiplied with x minus x1 and y minus is equal to y1. So these equations, right? These are the special cases, and the equation solution for this passing through this point will be y is equal to 5, and here we will have x is equal to 3. So hope you understood the concept and you understood how we can derive other formulas from it also. So in the upcoming videos, we will also learn about a few remaining different types of line, which we will derive with using this formula. So goodbye till then. Thank you.